Okay, so here's the next part, and we're going to go ahead and continue where we were. We had loaded in this what we call a rat's nest, just really a rat's nest of components and wires, and we're going to now assemble all these things as they would be assembled on our printed circuit board. So I'm just going to start out maybe, well, as always, I want to start out with the lower left corner here. Just put some information down here, put the date. This is version 1.0. And this is the 7805 demo for ECE 304. Spring 2025, UMass Amherst, ECE, department, and then my name. Okay, so we just have that documented. All right, and I'm going to start pulling components in here. So I'm just going to grab them. And this is going to be our LED. I'll expand it a little bit. I'm just going to kind of right now pull them all into the um, sort of the center of this workspace here. And though you don't have to, I'm going to lay these out following really the same basic positioning of the schematic. So we had so just, keep that schematic in mind. And if you want, you could take the PDF that we created of the schematic and have that in front of you. I'm going to have a resistor here. Okay, I've got an output connector here. That's J2, 5 output. Okay, we have VN over here. I'm going to put that here. U1 is our 7805. We have our C1 is our first capacitor. It sometimes when you click on one of these darn things, it it gives you a piece of it to drag and not the whole thing. Uh, there we go. We have our output capacitor there. I'm just rotating these, and all these little blue wires are the actual connections, the wiring connections that we specified when we did the schematic. And we're going to be working with those and moving them around. Okay, let's just get everything sort of roughly in place right now. Current test. Test point one. Come on now. Maybe I have to zoom in more to be able to move these, to grab and move. Test point one was for measuring that input voltage. And then test point two, oh, that's for measuring our output voltage over here. You'll notice that what's missing from here is our switch. Okay. And that's because the switch didn't have a footprint. So I'm going to have to go and manage the footprint libraries here. And we're going to have to add a footprint for that switch. And when we added a symbol, what we did is we opened up this file and went in and grabbed the actual symbol icon. Here, what we do is we click on the folder and it'll open. Okay, a library already exists, but I'm going to add it anyway. I'm going to get rid of the previous one so that I don't have a problem with double name. Come on now, delete. Okay. Um, did I add that? Okay, remove invalid cells. Let's see if I did this correctly. I'm going to update. Here, we're adding the switch footprint. So what I just did is I selected this button. Let's back up to see what I did. I'm in the PCB, the printed circuit board editor. I went to preferences and I managed the footprint libraries. And I pulled in the footprint for that switch. And then after that, I updated the PCB with this symbol here. And let's go ahead and update it. Close. And now we have the symbol or the footprint for that switch finally. Okay, so we're going to take this thing here. It's a little less of a rat's nest, but it's still kind of rat's nesty. And we're gonna turn this into our PCB. Now, one of the things that makes this challenging is that our customer asked us to put this on a printed circuit board that has a an area of less than 1 square inch. And so, 1 inch is 2.54 centimeters, 25.4 millimeters. So what we're really shooting for is something like 25 millimeters vertically, 25 millimeters horizontally. Um, and in reality, it's going to be longer than it is wider, but that's okay. But let's just pull in this ruler and see where we are right now. So you can see here we're at 100 millimeters. So this thing is already 25 millimeters is an inch. So we're already spread out. We're 4 inches across, and right now we're 4 inches by 2 inches. So that's 8 square inches. We really need to compact this by a factor of eight. I'm going to press the escape button to get out of that. And so we really need to compact things. And this is where you can spend a lot of time, on the design of one of these. But what I'm going to do is uh, escape this. I'm going to go back up here and select cursor so I can be moving things around. So I'm just going to bring this down here, the switch here. Okay. This capacitor, I'm going to rotate. And I'm just going to be bringing things kind of closer together. All right, we have VN in our VN test point. Okay, we have our switch and then the test point associated with measuring current. And maybe I'll take that and move it over here. Now, the switch has a slide on it. It's a slide switch, and the slide is going to be up on this side. So the connections are going to be in the bottom row, and the slide is going to be on the top row. So when we make the edge, what's called the edge cut of this board, we're going to actually have the edge right up against this upper edge of the switch. Okay, so you can see that we're starting to get it smaller. Okay, I'll bring the diode down here. We have that resistor there. We still have a lot of space in here, but we are making it smaller. Test point and then the output. Okay, I could perhaps rotate that. Okay, so it's getting smaller, and you can see that these components are all oriented very similar to the schematic, and that makes it easier to look at the schematic and look at the PCB and understand the circuitry. It's not electrically required to do that, but I'm certainly doing that on this first one for simplicity. To see what this thing is looking like so far, I'm just going to go up to View, and I'm going to look at the 3D viewer. All right, and this is what our board is looking like so far. So we have the what you see there in white is silk screen. That's not electrically important. That's just documentation printed over the top of the circuit board, the way you might have some silk screen printed on a t-shirt. And then what's important is all of these different holes. They all have the right drill hole diameter according to the footprint of the component. And these holes go from the top to the bottom. So you see, let's go to the other side. So what you see here is a pad on the top, a pad on the bottom, and then a through hole that's connected with conducting material all the way through. So we're going to put all the components on one side, grab the wires on the other side, and then solder them to all these pads. And the pads are going to be connected between the two sides of the board. Now, when we run all the wires, what we're going to do, there are a variety of ways of doing this. My preference is to run all the ground wires on the bottom and everything that's not a ground on the top. And so you can see it's starting to look closer like a PCB, but there's still a lot of white space on here that I want to try to get rid of. It also tells us that the board outline is missing, and that's we'll get to that. We'll actually define the what's called the edge cut in the outline of the board. To get a sense of our size now, I'm going to bring up the ruler. Okay, so our height is, it looks like it's about 19 millimeters, so that's less than an inch. But going this way, we're really at 51 millimeters, 2 inches. So this board has a surface area of 2 square inches, and so we'd really like to cut that in half, and that means consuming some of the white space in between. Okay, now there are a number of things we can do here. Let me at this point start talking to you about all the different layers. So you see all of these different layers on here. And let's go to the one that says fab. And I'm going to shut that off and then on. This is just a documentation layer for us. So you can see that a lot of these labels go away I'm clicking this on and off. On, you can see an I. Off, you can see a slash through the I. And I'm going to keep that off because this circuit is relatively uncomplicated, that we don't need all this. This is all the documentation, the labels and things for the various components. It's not going to be on the PCB itself, but this is just there as documentation for us in this fab layer while we're building this. So I'm going to keep that off. Okay, the other things I want to show you are there is something called a courtyard here, and I'm going to shut that off. And you can see that all those sort of magenta colored lines went away. The courtyard it just tells us how closely we can keep components. We don't want to run components with the courtyards right up against and touching each other. So that just helps us keep the spacing between the components. Okay, I'm also going to turn off the silk screen. That's here. F silk screen is the front layer. Turn that off. And that shut off all of that documentation layer. So if I were to shut off the front silk screen and the front courtyard, this is what our PCB is looking like so far. It's really just a whole bunch of pads, solder pads, and drill holes between the top and the bottom of the board. Okay. Right now we're looking at the front of the board. We can also look at the back of the board. Okay. And let me put back on the silk screen. Okay. Now, what we're working on is a two-layer board, front and back. And so when we're working on traces at the top or the front of the board, we'll make this F.cu, the front copper layer, active. Then when we do the grounds, we'll do the back copper layer and make that active. So this part can be confusing here. It's one of many things that can be confusing. But just to remind you, we have the front and back copper layers. We have silk screen. I can turn that off. Right now we have no silk screen on the back, but we'll add something in a little while. Okay, I'm going to start moving things around a little bit here to try to compress this. I'm going to put some of these labels down here, and that'll allow us to compress things a little bit more in space. Now, do you need these labels? They take up space. Do we need them? Sometimes you can take them and kind of tuck them right in there. Certainly, when you get the board and you're building it, it's very helpful if you if you look at this and the silk screen says C1, then you know you're going to have capacitor 1 there. You go to your bill of materials and you know what capacitor 1 is. If you don't have these labels there, it does make things harder for you. So I'm going to put this one in here. I'm going to see if I can shrink that a little bit. Mhm. Maybe I'll make that 0.6. Okay, so that worked. That shrunk that one up a little bit. Um, what else? TP2, I'm going to do the same thing. I'm going to put it in here. I'm going to rotate it. That one seems to fit okay. TP3, I'll put that in here and rotate it. Okay. But you can see we're now able to compress things in space a little more. And so really it's just a matter of moving things around. Um, if you look at the let me expand this. You'll notice that a lot of these pads are labeled GND. GND, this one is GND, GND. And we were able to do that because when we built the schematic, we put a ground symbol in there, and that defined a global ground. And that makes it easier for knowing where all the grounds are. And I'm going to orient them so that all the grounds are on the bottom. That's a personal preference. So if we look at this one, ground is on top. I'm going to rotate this so that we have ground on the bottom. Ground on the bottom. And we'll find sometimes this is helpful and but not always. Okay, ground on the bottom. I'm going to bring this symbol down here, rotate it. Okay, we have TP3. I'll move this over here. All right, now soon we'll be, we'll be at the point of diminishing returns for the purposes of this video. That is, I don't want to spend, an hour um, shrinking this. If we were doing a real design and we were really cost conscious, you pay when you build a PCB, you pay per square inch. And so when we're ordering these, the kind of ordering we're going to do is you'll get 3 PCBs at $5 per square inch. And that's in case you screw up the first one when you're soldering, you have a couple others as backups. Um, and so that's five bucks for 3 per square inch. That's $1.67 per square inch. You can order them in higher quantities and get it down to $1 per square inch. But however you do it, you're paying per square inch. And so your cost on the board is directly related to their physical size. All right. I could perhaps tuck this resistor in here. Okay. And this may be about as small as I want to make this. All right. I'm going to get this symbol down here. It's looking all right, I think. Let's get the ruler and see what our size is. So we're at 16 millimeters. Now, 25 millimeters is an inch, so we're quite a bit less than an inch there. And here we're at 30, a little bit more. So we're pretty close here to 1 square inch at this point. And I'm going to leave the size at that. Um, what I need to do now is put an edge cut layer. That's going to define the actual physical size of the board. So go to this one where it says edge cuts, and we're going to open up a box, And we're going to put one edge here and the other edge here. And that actually defines the size of the PCB. That's how our board is going to be cut from a larger sheet of copper clad board. Okay, let's escape out of that. We need to wire this up, but let's go back and view it in 3D. Okay, so it's reasonably compact now. Um, a couple of problems we've got. They're not electrical, but they're aesthetic, and they will be flagged by the design rules checker. You can see that SW1 is overlapping this pad here. R1 is overlapping this. Those will come up as warnings for us. Um, and so let's go ahead and move those away if we can. Whoops. And I might even shrink it. 0.6, 0.6, make it smaller. Okay, so that solves that one. And maybe I'll just do the same thing with this one. 0.6. Now, there are a number of design rules that are specified by the manufacturer of the PCBs, and we're using default rules right now. But among the kind of design rules are how small you can go with the various sizes of different components on there. We're not going to worry about that kind of detail at this point. Now what I want to do is start to wire this up. So let's open it up and make it big enough for us. Okay. So what we can see is all those blue traces, and we're going to have to turn those into actual wiring connections. And we may find that we have some problems where wires are crossing and they can't cross each other because they're going to be traces of copper. So I'm going to click on here. We're in the front copper layer, and I'm going to select this root track. See, it looks like sort of a piecewise linear thing here. I'm going to select that, and that's going to allow us to start doing our wiring. So I'm going to start here at J1 as our input. Click on that. That goes to TP1, and then that comes up to here. Okay, to our switch. All right. Um, the output from the switch in sort of turn on mode is going to go down here. But you can see it had to route around pad 3 to avoid creating a short circuit. So that's one of the things that this routing does. And we may find as we're trying to build this that we have the pads going around, the wires going around in a lot of different places to avoid crossing over each other. And we may find we have to sort of do some remedial work to fix that because I'm already worried about the possibility of a wiring problem in here. What I need to do is connect this one over to this one, and that's okay. Now, so this is our switch again. In one position, we go from 2 to 1, and then we come down to our capacitor. Okay, and we're also going to have to go to the input of the uh, 7805, and I may just be able to connect to it right there. Okay. For this other mode here, where when we have our switch connected to position 3, we have to connect it to here. Okay, it's gone down and it's found its routing all the way down here, right? You can see it's come down here between these pads around and up. And it's just doing that to avoid creating any short circuits. So we're okay with that. Okay, here we have all grounds. We'll worry about that later on the underside of the board. But what we've done so far is we've taken our input connector. We have our test point 1, our positive voltage. We're going through our switch. We're going to capacitor 1, and then we're going to the V in of the voltage regulator. And now we're going to start at V out of the regulator. And that has to go to a number of places. It's going to go to the resistor. It's also going to go to capacitor 2. Um, and it has to go to test point 2. And then down here, it's going to go to connector 2, connector J2. Okay, so there's that. Um, we have to now do the connection between the other terminal of the resistor and the anode of the LED. And it's when we route it, it's not going to be able to come right across this, so it's going to snake around. You'll see. Okay, so you see that this thing is clever enough to do routing around things as needed to avoid short circuits. Because if we had taken this one and ran it directly across R1, we'd create a short circuit. Okay, I think all that's left to do at this point is our grounds. And so now I'm going to go and make the bottom layer active, and that's going to do traces that are in blue. So we'll start here, ground, 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 and then we have to come up to here. And I think that's, oh, we have one more up to here. Okay, so now over here, it looks like we have a blue trace that is a ground trace sitting on top of a red trace. But keep in mind, the blue is on the underside of the board, the bottom layer, and the red is on the top layer. And so I can shut off these layers. Let's shut off the top layer. This just shows us all of our grounds. All right, I will shut off the bottom layer, and this just shows us our top connections. Okay, so so far so good. I think I'd like to add a, let's see, our top silk screen layers here. Remember, this is just documentation for us. Um, but I want to do something on the bottom now. I want to do a bottom silk screen. And I'm just going to open up a box, a text box here. And I'm just going to write, this is documentation on the back side of the board. So this is our 7805 voltage regulator. ECE 304, spring 2025, D. McLaughlin. And then I'm going to put today's date, 2/12/25. Okay. And so that's going to be on the bottom silk screen layer. And it's pretty big. I'm going to shrink it, but no matter where I put this, it is going to overlap with um, some of those copper pads, and that's going to be okay because this is just silk screen. It's just for us to see. It doesn't have electrical significance, so I'll just put it right here. But I do want to see if I can shrink that. Having trouble grabbing it. Let's see. I'm on the bottom silk screen layer. I'm going to shut off everything else to make it easier to see this. Turning off the top silk screen. All right, can I grab this? Okay. Properties. Okay, I just want to make this smaller. 0.5, 0.5. Okay, there it is. So now I can take it and I can kind of move it around a little bit and tuck it into things. It's we read it reversed, and that's just because we're looking at something on the underside of the board. Okay, I'm going to turn things back on. We have our top copper layer, our bottom copper layer, our front and back silk screen layers. Okay, and this is our, I think it's our completed PCB. I'm going to run a design rules checker here. Okay, so look at the warnings. It's telling us that we have a text height out of range, Okay, and these have to do with design rules. The manufacturer is telling us that you have a minimum height of zero point 0.8 millimeters, and I'm using zero point 0.5. So I'll have to. These are warnings. It looks like I need to go back and change some of those things that I shrunk here. Otherwise, they'll be out of spec, and I just don't want to cause a problem here. So we have this box that we just created. We have to make that zero point 0.8 instead of zero point 0.5. Um, and then we also have these other labels that I sort of cleverly created. Okay, I have to make these zero point 0.8. Okay, that one. R1, it didn't like zero point 0.8, zero point 0.8. Okay. Now, of course, once we do this, let's see, looks like S1 is going to be okay, but R1 is going to be up against that silk screen layer. Maybe I can move it a little. Then it's gonna yell at us that R1 is near the copper layer. Okay, I think we've got R1, so it's not touching anything else. Okay, we had to do TP1. Yeah, yeah, we didn't get away with making that zero point 0.6. It's supposed to be a minimum of zero point 0.8. Okay, now when we do run this, it's gonna complain that TP1 is sitting over a trace. But we'll go ahead and let that happen and see how it looks. See if I can click on this one. This one has to have a minimum of zero point 0.8. So remember, these are all design rules for our specified uh, board manufacturer, and we're going with the defaults that are on here. We could go to the manufacturer. We're using OSH Park, and we could look up all of their design rules. But instead, we're just going with the defaults on the assumption that the defaults here are going to be consistent with the vendor. Um, okay, I'm going to rerun this thing. All right, it says silk screen is clipped by the solder mask. Uh, uh, okay, and that's our commentary down the bottom. We realize that it's going to be clipped by the solder mask. It's because it's that silk screen is sitting on top of some of these pads, and so what can we do about that? I'm just going to let it go. It's a warning. I'm going to accept it. I'll show you what it looks like. I'm going to go ahead and view this board. Okay, this is what it looks like on the top. And then if we look at it on the bottom, this is the consequence of that overlap. So when we get it back, um, we're, we have this label. It's sort of partially obscured. I see I have a typo in there. Um, if we wanted to, we could break this into two boxes and put one up here and one down here. Um, Maybe I'll do that just so that we can sort of get this thing done without any warnings at all. Um, so okay, I think what I'll do is get rid of one line here. In fact, I'm going to make two boxes. One of them is just going to say 7805 voltage regulator. Okay, and okay. Okay, I think in this position, it's though it looks confusing, it's not going to be interfering with anything on the bottom. In fact, let me shut off. I'm going to shut off the front silk screen, and I'm going to shut off the front copper. So we're really just looking at the bottom here. So you can see that this is not interfering with anything. I'm going to add another text box that has my name and the date, 2/12/2025. Okay, and I'm allowed to get away with 0.8 millimeters by 0.8 millimeters. And I can put that up there. Okay, I think that's going to be okay. I'll now do an inspection design rules checker, run it again. All right, no errors. That's nice. I'm going to view it again in 3D. Okay, there's the front view, and then there's the back view. Um, Now I can tell you last year I when we had these manufactured, we had a handful of students that didn't put their name on there, or they put their name in a place that wasn't visible, and they didn't do this check to be sure. And as a result, we had hundreds of PCBs that came back from the manufacturer, and some of them we had no way of giving back to the students because they didn't have their name visible. So you clearly want that on there. Okay, but there's our PCB design. Okay, and the next thing I want to do now is, I mean, we're done with the design for the most part. What I want to do is save it. Okay, and I'm going to verify that the board actually works. So I'm going to go back to the file that contains this design, KiCad projects 2025. This is our demo. Okay. And we have all these different files on here, backup files and various things. What I'm going to do is I'm going to take this PCB file and I'm going to load it onto the OSH Park website, and we'll see whether it would get accepted. I'm not going to do a purchase right now, but let's see, we don't need this anymore. I'm going to go to OSH Park. That's our chosen vendor. Okay, we could log in. You don't need to log in. That's it. That's to create an account and things. But what I'm going to do is just get started by taking this PCB file and dropping it right on there. And they will analyze it and make sure that the board has everything that's needed so that it can be manufactured. Okay, there. So it detected a two-layer board, 1.2 by 0.7 square inches. I'm sorry, 1.2 by 0.7 square inches. Let me see what that is in square area. 1.2. It's 0.84 square inches. So we're sort of well under our goal of 1 square inch. You can see what the top looks like and what the bottom looks like. That is when we get them back from manufacturing. This is what they're going to look like. The black will have been drilled out. You'll have copper there. You'll see the silk screen, and then there will be a copper mask in between all the copper pads where no solder will adhere. Okay, let's see. See if we can continue here. I guess we can't continue without logging in, and then we'd get into more information about how long it would take to manufacture this. But there's our completed design, and it has passed the test that we have available to us, design rules and things like that. And we're done.